It is difficult for us, living in an age of DNA testing and genetic sequencing, to truly grasp the chaos that reigned over biology at the dawn of the 20th century. History has preferred to forget the embarrassing confusion of its greatest minds, but we must look closely at the dust they kicked up to understand the clarity one woman brought to the storm. Before 1905, the question of what determined a baby's sex was not a matter of science, it was a matter of folklore dressed up in academic robes. For centuries, humanity had been stumbling in the dark, grasping at theories that seem laughable today. Aristotle, the great philosopher whose shadow stretched across millennia, confidently asserted that the heat of the male partner during conception was the deciding factor. If the passion was high, a boy was born. If it cooled, a girl. Others swore by nutrition. If a mother ate well, she would produce a female. If she starved, a male. Or was it the other way around? The theories were endless and contradictory. Some believed it was the phase of the moon, others the direction of the wind, or even which side of the bed the parents slept on. It was a biological lottery, a roll of the dice with no explanations, only superstitions. By the early 1900s, biology was trying to professionalize itself, yet the giants of the field remained skeptical of the invisible mechanics of life. Enter Thomas Hunt Morgan. Remember that name, for he is the antagonist in this drama, though history books often paint him as the hero. Morgan was a titan of science, a man of immense influence and intellect, but he was also stubborn. He vehemently believed that chromosomes, those tiny thread-like structures visible inside cells, had absolutely nothing to do with heredity. To Morgan and his circle, chromosomes were merely cellular debris, irrelevant byproducts of a cell's life, not the architects of it. The idea that these microscopic specks could carry the blueprint of a human being was to him a fantasy. In the shadow of these loud, confident men stood Nettie Stevens. She was not the typical prodigy the academic world fawned over. She was 39 years old when she finally began her research career, a late bloomer by every standard of the era, and a woman in a field that barely tolerated her gender. She had spent years saving money as a school teacher just to afford the education these men took for granted. While Morgan and his colleagues debated grand theories in lecture halls, casting their voices over the heads of their students, Nettie Stevens went to the microscope. She did not deal in bluster or ego, she dealt in evidence. She arrived at Bryn Mawr College and later the Carnegie Institution with a quiet determination that unsettled the status quo. She wasn't there to guess, she was there to see. The scientific establishment, led by men like Morgan, was busy building castles in the sky, constructing elaborate arguments about environmental factors determining sex. They were looking at the world around them for answers, at food, temperature, and weather. Nettie Stevens, however, looked down. She looked into the lens, into the very fabric of life, preparing to dismantle centuries of guesswork with a single, undeniable truth. She was about to prove that biology was not magic and that the titans of science were wrong. But before she could change the world, she had to find the perfect subject, a humble crawling beetle that would soon become the most important insect in the history of genetics. The year was 1905. The setting was a quiet laboratory far removed from the spotlight of fame that men like Thomas Hunt Morgan enjoyed. Nettie Stevens was engaged in a task that would have driven a less patient mind to madness. She was dissecting and analyzing the reproductive cells of Tenebrio molitor, the common mealworm beetle. To the outside world, it was unglamorous, tedious work, but under Stevens' lens, a drama of cosmic proportions was unfolding. She wasn't just looking, she was hunting. Stevens was meticulously observing the chromosomes during cell division, specifically in the production of sperm cells. What she saw was a distinct pattern that defied the random chaos her male contemporaries believed in. She noticed that the female mealworm cells contained 20 large chromosomes, but the males? The males were different. They possessed 19 large chromosomes and one peculiar stunted little partner, a mismatch, an anomaly. This was the eureka moment, though it likely happened in the silence of deep concentration rather than a shout. Stevens realized she was looking at two different kinds of sperm. One kind carried the large chromosome, what we now call the X. The other carried the small one, the Y. She tracked them relentlessly, applying a rigorous logic that was absent in the wild theories of her time. When an egg, which always carried an X, was fertilized by a sperm with an X, the result was a female. When fertilized by a sperm with a Y, the result was a male. It seems simple to us now, taught in every high school biology class, but in 1905, this was heresy. Stevens had found the biological switch. She had proven that sex was determined at the very moment of fertilization, dictated by these microscopic structures. It wasn't the heat of the room, it wasn't the mother's diet, it was a hard chromosomal fact. She wrote, with characteristic precision, "This seems to be a clear case of sex determination, not by an external factor, but by the peculiarity of the spermatozoan." While Stevens was finalizing her revolutionary paper, another scientist, Edmund Beecher Wilson, a friend and colleague, was stumbling toward a similar conclusion, but there was a critical difference. Wilson was hesitant. He equivocated, suggesting that the chromosomes might just be a symptom of sex differences, not the cause. Stevens did not blink. She asserted causality. She argued that the chromosomes were the cause. Her work was bolder, clearer, and more definitive. Yet, the reception was chilly. When she published her findings, the establishment pushed back. Thomas Hunt Morgan, her own mentor, was one of the loudest critics. He dismissed the idea that sex could be Mendelian or controlled by chromosomes. He argued that Stevens had mistaken cause for effect, or worse, that she was seeing patterns where there were none. It was a classic case of a paradigm shift hitting a brick wall of established dogma. Stevens held firm, her data impeccable, her illustrations precise. She had handed the scientific world the key to heredity, the very foundation of modern genetics. But instead of bowing to her discovery, the gatekeepers of science prepared to take the key and lock her out of the room. She had solved biology's biggest mystery, but she had committed the unforgivable sin of being a woman who was right when her male superiors were wrong.
The tragedy of Nettie Stevens is not that she was forgotten by accident. It is that she was erased by design. The erasure began not with silence, but with the faint praise of the very man who should have championed her. Nettie Stevens died of breast cancer in 1912, just 7 years after her groundbreaking discovery. She was only 50 years old. With her voice silenced by death, the narrative of her life became clay in the hands of the survivors, specifically Thomas Hunt Morgan. Morgan, who had spent years arguing against Stevens' theory, eventually came around. In fact, he did more than come around. He built his entire career on the foundation she laid. By 1910, Morgan had begun his famous experiments with fruit flies. Experiments that would confirm the chromosomal theory of heredity. But when he looked back at the origins of this theory, he adjusted the focus. In his obituary for Stevens in the journal Science, Morgan wrote words that haunt the history of women in STEM to this day. He described her as having a trustworthiness and patience, qualities he attributed to a good worker, not a visionary scientist. Then came the dagger. He characterized her as a technician with keen powers of observation, but dismissed her theoretical mind. He wrote that while she was excellent at seeing details, she lacked the broader scientific imagination to understand their implications. It was a staggering act of intellectual theft. By labeling her a technician, Morgan stripped Stevens of her agency. He reduced her from the architect of a revolution to a mere bricklayer who happened to put a stone in the right place. The insult was calculated. It suggested that the discovery of sex chromosomes was inevitable, something that keen eyes would spot eventually, rather than a leap of deductive brilliance that contradicted the era's dogma. This narrative stuck. For decades, textbooks cited Morgan and Wilson as the fathers of genetics. Wilson, to his credit, was always more generous to Stevens, acknowledging her priority in his own papers. But Morgan was the one who won the Nobel Prize in 1933 for his discoveries concerning the role played by the chromosome in heredity. Discoveries that were directly built upon the proof Stevens provided. This is the Matilda Effect in its purest, cruelest form. A woman's brilliance is absorbed into the biography of the men standing next to her. Stevens was not just a pair of eyes. She was a rigorous experimentalist who interpreted data that baffled the men around her. She didn't just see the X and Y. She understood what they meant. Today, we drag her name out from the footnotes. We scrape away the layers of Morgan's dismissal to reveal the scientist underneath. Nettie Stevens gave us the answer to one of humanity's oldest questions. She proved that we are not shaped by the phases of the moon or the temperature of our conception, but by the elegant mathematical dance of chromosomes. History tried to turn her into a ghost, a helper, a technician. But the truth, like the chromosomes she discovered, is indelible. She was the pioneer. And it is time she stood alone in the light, no longer in the shadow of the men who took the credit for her genius.